Okay, we have already covered graph of y equals f of x and then greatest integer of it. Okay, we have already covered it. And now the second graph, second transformation on greatest integer is y equals f and greatest integer of x, which means in this particular case we first draw y equals fx and then take integer part of it. However, in this particular case, input to this is greatest integer of x. This graph is comparatively easier than y equals greatest integer of fx. So what we actually do, we draw f of x like we earlier, this is what we have done. In this particular case, y equals greatest integer of fx, we had drawn lines parallel to x-axis. In this case, we will be drawing line perpendicular to x-axis. Okay. So let's start. First case is f of x equals e raised power greatest integer x. This is y equals e raised power x. Then we have drawn x equals 0. X equals 1, x equals minus 2, x equals 3, minus 1, minus 2. Why we have done this? Because input to this f depends upon greatest integer of x. So even if value lies between 0 to 1, input to f will be f of 0. Suppose x lies between 2 to 3, input will be f of 2, right? So at x equals 0, this is x equals 0, this is x-axis, this is y-axis, this is origin. Okay, between 0 to 1, greatest integer of x will be 0, which means input to it will be e raised power 0, which means 1. And then between 1 to 2, greatest integer of x will be 1. So input is 1, e. Then between 2 to 3, input is 2, which means output is e square. Then e raised power minus 1, e raised power minus 2. Okay, at x equals 1, if you put x equals 1 here, output is e raised power 1, not e raised power 0. So at this particular point, we choose value from here and refuse from this point. Okay, so between 0 to 1, output is 1. Between 1 to 2, input to e raised power something is 1, output is e raised power 1. Between 2 to 3, input is 2, which means output is e square. Okay, second, f of x equals log of greatest integer of x. We have drawn log of x, then lines perpendicular to x-axis, x equals 0, x equals 1, x equals 2, x equals 3, x equals 4. Between 0 to 1, input to log will be 0, which means it will not accept. So this graph does not exist between 0 to 1. For this particular graph, x should be greater than equals 1. So between 1 to 2, greatest integer of x will return 1. So input is log of 1, which means 0. So value is 0. Between 2 to 3, input, if x is between 2 to 3, x lies between 2 to 3, then input is 2, which means output is log 2. This value is log 2. Likewise, this is log 3. Probably I am doing it in a haste, but it's very easy graph. Okay, f of x equals sine inverse greatest integer of x. This is sine inverse x, and then x equals 0, x equals 1, x equals minus 1. Between 0 to 1, input to sine inverse will be 0, which means sine inverse 0 entire this x-axis. At x equals 1, output is pi by 2, because at x equals 1, if we put x equals 1, this is sine inverse 1, which means pi by 2. So arrow at this particular pi. Between minus 1 to 0, if x lies between this, greatest integer of x is minus 1. Sine inverse minus 1 is minus pi by 2. In this range, output is this, which means sine inverse will accept -1. So sine inverse -1 is pi by 2. This is pi by 2. Between 0 to 1, 0, add 1, pi by 2. Between -1 to 0, output is minus pi by 2. Next graph, sine of greatest integer x. Again, this is x-axis, y-axis, this is 0, this is pi by 2, pi. At x equals 1, graph intersects at this point, x equals 2. Basically, we have drawn sine x and then lines perpendicular to x-axis at integer intervals. X equals 0. So if you choose x lies between 0 to 1, if x lies between 0 to 1, x lies 0 to 1, then sine of 0 we need to calculate, which means 0. This is my value. Between 1 to 2, between these two intervals, greatest integer x will be 1, which means output is sine 1. This is sine 1. However, I should have avoided this arrow, but okay, let's do it. Between 2 to 3, between 2 to 3, greatest integer of x will return 2, which means sine 2. Output is sine 2. Then this point is 3. Between 3 to 4, output is sine 3. Between -1 to 0, output is what? This is -1. X equals -1. This is sine minus of sine 1. And then I think it's not difficult to understand why these arrows are. I put this arrow here and this arrow here means discontinuity. I don't think I need to explain this. You have already done a lot of things in my earlier lecture. Okay, f of x equals cos inverse greatest integer of x. Again, we have drawn cos. This is pi. This is pi by 2. X equals 0, 1 and -1. If x lies 0 to 1, then greatest integer of x is 0. Cos inverse 0 means pi by 2. So this entire range. But at x equals 1, cos inverse 1 means 0. This is my output. Between -1 to 1, if x is -1 to 1, sorry, -1 to 0, greatest integer of x is -1. -1 means pi. So between -1 to 0, output is pi. Between 0 to 1, pi by 2, and exactly at x equals 1, your answer is 0. There are two discontinuities at x equals 0 and at x equals 1, left hand discontinuity, right? Okay, done. We have hopefully covered everything.